Can you hear me? Yeah? Right, so threads. Yeah, I started using Ruby in 2007, and I never used threads in application code, never ever. The only reason why I know that threads exist is because I had some thread-related bugs in libraries that I had to fix. So I needed to learn how to use threads, but yeah. In Rails apps, never ever. That's funny. Yeah, anyway, I'm here to talk about Rom, latest version 4.0. So quick introduction, my name is Piotr Solnica. I'm a software developer from Krakow. And I work as a tech lead for a company called IceLab. We're a small consultancy from Australia, so I work remotely from Poland. And the cool thing is that we stopped using Rails roughly 2 years ago. And we've built our own stack based on dry-rb and Rom-rb libraries. So that's pretty cool. We try to contribute to both projects as much as possible and support them. And I will talk about Rom 4, which is here, sort of, because the first release candidate was released roughly a week ago. The code is kind of frozen. We only address any issues that people may find. So far, nobody found anything, so that's good. And in case you don't know what Rom is, I will explain it to you really quickly. So Rom is an open source persistence and mapping toolkit for Ruby, built for speed and simplicity. Now, there are like 3 things that are important here. The first one is that it's a toolkit. So first and foremost, it's like a collection of small components that are just combined together to provide a lot of functionality. So it's a collection of libraries, you can say. And it's been built for speed and simplicity, which means that it's supposed to be faster than existing solutions, and it's supposed to be simpler than existing solutions. Now, it's database agnostic, which means that you can use it with any database. In fact, you can use Rom with anything that provides data. Like the simplest adapter that you can build for Rom can be built for a Ruby array object, which is not a joke, because array can have data, so it can work with Rom. You can also use it with, obviously, SQL databases and literally anything else that you can write adapter for. And you should be able to write adapters for everything. It's flexible because, as I mentioned, it's a toolkit. So it's not a gigantic library. It's a collection of smaller libraries. Even if they are provided by a single gem, it's still a small collection of libraries inside. So if you, for example, would like to build some kind of a, I don't know, data migration system on top of Rom, you will find it very easy to do because there's a lot of APIs that you can leverage. And they are all treated as a first-class citizen within Rom ecosystem. It's also extendable because we have a public API for plugins. So you can build additional functionality and just plug it into Rom. And it's fast. Although I have to say that measuring performance and benchmarking one library against other libraries is kind of tricky. But so far, I've been watching that Rom is kind of fast, like much faster than Active Record, especially when it comes to processing bigger amounts of data. And it's simple. Of course, this is a relative term, so it's kind of hard to describe what simple means. But when you compare it to, for example, source code of other libraries that are kind of similar in functionality, you will see that Rom is actually much simpler internally. So that's basically what we want to achieve with this project. And we partially achieved it already, so that's pretty good. Now, you might be thinking that this sounds like some kind of a crazy object relational mapper, right? Because this is Ruby, it's an object-oriented language, so if we have a library that allows us to work with a database, then it's probably an object relational mapper. Now, an interesting fact about Rom is that it's not an ORM. And I know that we have the same letters in the name, but it's not the same thing. And the reason why it's not a typical ORM is that there's a bunch of things in typical ORMs that we just don't have, things that are problematic. So the biggest difference is that in Rom, there's no concept of a mutable object. So we simply do not have this idea that you load some object from the database, you mutate it in place, and then like save it back to the database. we don't have it. It doesn't exist. ROM is based on pretty much functional data processing. So it's a data processing pipeline that you take data from one place and you just transform it and eventually save it in a database or use it as a response in an HTTP request. We also have a much simpler association model, as in this piece of functionality that allows you to load associated data into some nested data structures. It's much simpler in ROM compared to how it works in other ORMs. And ROM doesn't have leaky abstractions. It's mostly related to building complex queries. In ROM, the query API is a first-class citizen, and you just write whatever query you want, and it's a first-class feature, right? So you're not bypassing some kind of ORM abstraction. You're just using a first-class API. Now, there are a few things that are specific to Active Record that we also don't have. So first one is obviously we don't have tight coupling between the database schema and your domain model because it's not an Active Record ORM. It's not an ORM in general. So you can load data however you want and map them to whatever you want. We also don't have n+1 query problem, which is something I always forget to mention, and it's so important. Like, we just don't have n+1 queries. It's impossible to have them in ROM. And we don't have callbacks, and we don't have gigantic API. So this makes ROM quite different from typical ORMs, at least in the Ruby world. Now, you might be wondering, why does it even exist? Like, what's the reason to work for many years on another library that allows you to work with a database? Now, the reason is to have a true alternative to Active Record. Like, we have SQL, obviously. We have a bunch of other libraries that are less known. And they are really mature, right? It's been like, I don't know, 11, 12 years, right? So that's quite a lot to build a powerful and mature library. And we all know them. We are productive when using them. So what's the reason? So the reason is that they are all Active Record ORMs, which is kind of weird because there's no real alternative. And the reason why there's no alternative is that Rails made Active Record the standard. So everybody in our community, when they think about databases, they think about Active Record. And this is a pattern that influenced so many things in our community. Even when you're building, I don't know, something to work with an HTTP API, you're going to build something Active Record-ish, because that's what you're used to, right? And this is really limiting. Like, it limits what we can do with Ruby, because we're thinking through a single pattern that comes from patterns related to databases. So this is just weird. It's limiting us. And one of the biggest reasons why ROM exists is that it allows you to separate persistence concerns from your application domain, which is something you cannot do easily with Active Record. You can do it by working around the pattern itself, but it makes no sense to like fight the library that you use. Your library should help you, right? Okay, so what's the deal with ROM 4.0? This is a big release. It improves a lot, and it's serious business. So let's take a look. First of all, we've had a big challenge when working on ROM. At least me personally, since the very beginning, I always wanted to have a library that is more powerful, more flexible than Active Record, yet it is as easy to use as Active Record, which is actually a really big challenge. Now, if we want to make ROM as simple as Active Record, when we're, for example, starting a new project, we just need to leverage various meta-programming features in Ruby. So let's remind ourselves what's so awesome about Active Record. I know that if you're writing Ruby, you are probably familiar with Active Record, and you probably know it very well. But if you're using something for a while, you just get used to it, right? Like, the awesome part of some library becomes just your standard thing, and you kind of forget why it's awesome in the first place. So let's just remind ourselves really quickly why Active Record is so cool. So for example, there's no boilerplate. Like, that's probably the best thing about it, because if you start a new project, if you're like defining your first tables, you're trying to figure out what columns they should have, you want to move fast. because things are changing rapidly in the very beginning of a project. An active record allows you to work with the data, work with the database, without even specifying anything in model classes. So that's pretty cool. If you want to save something in the database, that's one line of code. And this process of taking data from some place and saving it in the database is actually extremely complicated internally. And with Ruby, we can have it in a single line of code, which is really great. Now, loading data from the database using some kind of a query API is also so simple. We have a bunch of methods. We can call them in a single line of code, and it works. So it's pretty magical. Even making changes is very simple. I used a probably less popular example here, because it's much more in line with how Rom works. You can obviously load a user, mutate it, and save it back, but that's awful, so I'm showing you this. But again, one line of code, you just change data in your database. Pretty amazing. Now, this ease of use means that you have very little code to write when you start a new project. You can move very fast. And as I mentioned, things are changing rapidly when you start a new project, so this is really important. And there's a lot of functionality that you get for free. You define a class, it's empty, and you get a ton of functionality. And because there's no boilerplate, when things are changing, you don't have to change a lot of stuff in different places in your code base, because it's just magic. It works magically. Now, this was a real challenge for Rom. I say was because we solved it, so that's cool. Now, the reason why it was a big challenge is because in Rom we have something that I call a dynamic query interface, which is not tied to your database schema, which means that you can have any kind of a query, and we will always map results to data structures that are a true reflection of that query. So it's completely dynamic. Now, we have an explicit representation of the data structures that relations return. And relations basically allow you to access your database. And we always have the definition of these data structures. It's always explicit. Even if you don't see it, it's there. Now, we can map to struct objects that are decoupled from your database. This is one of the biggest differences between Rom and Active Record, because the data structures that we load are represented by struct objects, and struct objects don't have access to the database. So they are just pure data structures. Once you loaded them, they are there, and you cannot load more data, because they are just pure data structures. No database connection, nothing. And we don't have the idea of loading associated data in a lazy way. Like you have a user, you load a user into memory, and then you ask for, I don't know, a list of its tasks. And then Active Record would issue another query. But with Rom, you cannot do that. You need to preload it, like specify it initially that you're going to have a user with tasks, and then we're going to load everything at once. So despite all of these kind of constraints, this is fine because we made it. And of course, we made it through magic because it's Ruby, but it's good. Now, I'm going to show you a couple of very simple examples. And all you need to know is that we have relations and structs in Rom. And relations are kind of like models in Active Record. Although they are not classes, we use instances of relation classes. We use kind of instance methods exclusively in Rom. The only reason why you use class methods in Rom is when you're configuring some stuff, but at runtime, you only work with objects. So relations allow you to just talk to your database. I don't know, define some query, load some data, make some changes. This is the reason why relations exist, and they are like the most important part in Rom. And structs, it's kind of an abstract term in Rom. We do provide like an internal implementation of struct objects, but it's an abstract term. We just say structs to describe objects that represent data that you loaded from your database. And relations can return structs. They can return hashes, or they can return structs. So here's an example of a relation class. We also use convention over configuration. So the class is called users, plural, which means that by default, we're going to figure out that there is a users table, just lowercase. And we know that we will connect to this database table. Then we have this extra line of code, schema infer true. This is there because schema is a really important concept in Rom relations. So we want you to know that there is a schema and that we infer it from your database. So again, a lot of magic under the hood. We're going to figure out that the table is called users, and we're going to just load all the column information into Ruby objects and describe the schema using special attribute objects. And you can also like override them. But again, the simplest form is this. So compared to active record, there's this extra line of code, but still it's almost nothing. And you get a lot of functionality for free because an instance of this class gives you a lot of power. So we don't have boilerplate as well. We don't have to define attributes. You don't have to define complex configuration. It's a very simple class definition, and it's a lot of functionality for free. When it comes to persisting data, it's also very simple in Rom. We have this idea of change sets. You can have different types of change sets. So if you ask a relation for a create change set, pass in some data, and commit it, you just persist the data in your database. So again, one line of code, so simple, so tick. When it comes to queries, again, as simple as with Active Record. In fact, it's simpler than in Active Record. This is a trivial example, but you can have really complicated queries that are not easily achievable with Active Record. So queries, also so simple, even simpler. When it comes to updating data, it's also quite similar. Like with Active Record, you can restrict a relation to a name that equals Jane, and then ask for an update change set, give it new data, commit it, and you just update it. And you just update the data in your database. So again, one line of code, very simple, so tick. But there's, it looks similar, but there are a couple of things that are really different under the hood. First of all, when we load structs into memory, they are a true reflection of the query that you used. So by default, we have all the attributes, right? So users first returns first user with ID and name. And this means that this relation has ID and name columns, and that's it. If you select just one column, so let's say select name, you will see that you get back a struct with just a single attribute. Now, this is completely different than in Active Record, where you can also use a custom query, but it's going to return some weird representation of a model which may or may not have the attributes that are in the database table. It loads the attributes into attributes hash. Some attribute readers may not work, and you don't know why. Maybe you screw up the query, maybe it's fine. It's hard to say. So it's basically a workaround. Like you're just using a leaky abstraction, and you're using a workaround to use a custom query. In Rom, it doesn't exist. Like you have a first-class API that you use. Now, if you take a look at the classes of the return structs, you will see that they indeed include correct attributes, so ID, name, and just the name. Now, people obviously want their own methods, right? So in Active Record, you just define your methods in a model. That's pretty obvious. And then you have these methods available. Now in Rom, it's a bit more tricky because we can load different models. Depending on the query that you use, depending on the fact that you may or may not use associations, and so on and so forth. So what we did is that we introduced a feature called struct namespace, which means that you can define a module, which is the namespace, and define classes within that module. And Rom will figure out which classes it should use. So the way it works is that you can define it in a relation. So we say struct namespace entities, let's call them entities for whatever reason, and then within this namespace we have a user class. And again, through convention over configuration and all kinds of tricks, we figure out that user should be used with users relation. Now we define our own methods, and just like with Active Record, when we ask for the data, we get back our own models with our own methods. Now, the cool part here is that it's not restricted to like the canonical representation with all the attributes. Even if you select just a name, you still have access to the methods that you define, and it still returns your own entity class. Now, you might be wondering, what about associations? What if I have users and they have tasks? So in Rom, we have associations that look kind of similar from the DSL point of view. So you just say associations do has many tasks. When you define it, you can say users combine tasks, and it will give you back users with their tasks. So combine is kind of like includes or eager load in active record. Now, you can define your own methods, as I mentioned, and these methods often depend on the fact that there are some values under specific attribute readers. So in this case, we have has tasks predicate method, and it depends on the fact that tasks are loaded, right? So when you load users with tasks, it works. But what if you forgot to load tasks? So what if you do this, like users first, and there are no tasks? As I mentioned, we cannot load tasks like dynamically from the struct class, from the struct object, because it's not connected to the database. So what's going to happen is that you will get an error that says, well, there's no tasks method, so maybe you forgot to load this attribute. So this is a pretty big problem that we solve in a pretty simple way, and it allows you to work with the same class initially that may or may not have some data, and that's it. Now, what does this mean in practice? Like, we have spent a lot of time building pretty sophisticated functionality that uses a lot of meta programming, but why? So we have dynamic query interface that still works, even though there's a lot of like dynamic behavior under the hood related to structs. You still have access to queries that you can define however you want. You can have custom methods as well, and they are always available. And you end up with objects that are decoupled from the database, so you still have just plain data structures that are much simpler than active record instances. Now, this is awesome because you have the ability to start simple. You don't even have to define your own structs. It's actually quite common that you start without any struct classes, because like the attributes, the columns that you have in your database, this is enough in the beginning. So you just define relations and you use structs that they return, and that's it. So you can move really fast without even defining any models. You can eventually provide your own methods, but still it's quite dynamic, so you don't have to define attributes in your structs. You don't care whether you loaded some association or not. You have a single place to put your logic, and that's it. So again, you can move very fast. This means that we have active record-like convenience, but without tight coupling with the database. There are some restrictions, like if you have a test which wants to like check some struct functionality, and you're using this dynamic behavior of inferring struct attributes, then you will need to have a database connection. But again, this object will not be connected to the database, so it's still pretty fast. So even this type of tests are running really fast. So that's a trade-off, but again, it's worth it because you can move very fast when you start a new project. But as I mentioned, this is all about convenience when you start a new project. And this is something that Active Record is really good at, so it kind of influenced how ROM evolved in the recent version, simply because people need it. I experienced it myself when I started using ROM, started building a new project. It felt kind of sluggish in the beginning. Like, I would have to define different struct classes with a bunch of attributes, and then I would be like, okay, now I need a user but with some additional data, so I need to create another class that inherits from this base class, and there's just a lot of classes. And it's fine eventually when a project is big, but it's really bad in the beginning because you work slower than you could. So the trick is that this is not enforced by the library. Like, if you start a new project, it's up to you how you want to approach it. This magical dynamic behavior that I showed you with structs that are generated automatically, with schemas inferred automatically, with schemas that are adjusting dynamically based on your query, this is a lot of stuff that's going on under the hood, but this is not enforced by the library. Like, ROM doesn't enforce the this is how you need to use Rom. It's one of the ways of using Rom, right? It's not the single way of using Rom. And it means that at any point in time, once you feel that you really understand what you're doing when you're building an application, you can start defining some explicit classes. And maybe you want to define your own attributes. Maybe you want to use some custom types for these attributes. And then Rom just loads them, right? So this means that you can establish different models based on various domain concepts. So instead of a single user model, like in a typical Rails application, you may have a user and an admin and maybe a profile. And you can like cherry pick which attributes should be loaded based on what the domain is saying. Now, in order to get there, you need to actually spend some time prototyping the app and understanding the domain itself. So as I mentioned before, this is not something that you can easily do in the very beginning. That's why it should be possible to move quickly in the beginning, but once you want to be more explicit about your data structures, about basically the entire API that you're building for your application, then you need to have a way to do this easily with a given library. Now, Active Record is great in the beginning, but then we're not really sure what to do, right? And this is something that has been bothering me for years because it's a problem that we identified like in 2008 or something, and it's 2017. So this is a process. Like building an application is a process. It can take a couple of years. And if your application is growing and it's kind of becoming more and more complicated, when you're using Rom, you can actually do something about that. You can achieve better encapsulation with Rom. You can define data structures that are specific in given contexts. You can just be more granular when it comes to the data that you're working with and when it comes to the interface that you use to get the data. And this is something that Active Record just doesn't provide, and Rom does support this process. Okay, so this is kind of a quick show-off mode. I'm going to show you 10 things you can do with Rom that Active Record cannot do. So the most obvious one is, of course, you can use it with different databases, not just SQL databases. So let's say you're using Mongo for whatever crazy reason. You can do it. It's pretty similar. You just define a class that is a relation, and you need to define a schema explicitly because Mongo is schemaless. So you need to do it explicitly. It's fine. It works. Number 2. This is the latest addition. With Rom 4, you can define cross-database associations. And I know that this sounds crazy, but people do that in production. It's sometimes needed. So in Rom, it's pretty simple. Let's say you have 2 relations. One is from an SQL database, and the other one is from a YAML file. We have a Rom YAML adapter, actually. And all you need to do is say, has many tasks. We're going to override the default query logic. We say that there is a special method called forUsers, which returns tasks for a collection of users, and you're done. And it works between different databases, so that's pretty cool. Number 3, you can map to any model. As I mentioned, you can eventually start defining your own models, and they don't have to inherit from Rom struct. It can be anything. So let's say you have your supermodel library. There are like 50 of those. So you can say map to my user, and you're going to get back your own my user instances. And that's all you need to do. Number 4, you can project data easily and get back convenient structs. Now, this is actually a big thing. Maybe it looks innocent, but it's actually a really big piece of functionality. What it means is that you can leverage the query API of your database to just get whatever data you want. Let's say you want to have posts represented with just a title, and let's say you have a comment count that is inside some meta JSON field. Now, you can just do this, and we have really good support for JSON fields in Postgres. So you can say like get text comment count chorus to integer and call it comments. And you still get back a struct which is a true reflection of the query that you used. Number 5, you can easily construct complex conditions. So I know that Active Record supports OR, finally. We support OR as well. But we can do other things, like you can negate a condition. You can use JSON fields inside conditions, and you can do all kinds of other complex conditions really easily. And this is all thanks to the way schema attributes work. So number 6, you can also use SQL functions. So this is related to projecting data. You can also use SQL functions to project data and create just virtual attributes that actually don't exist in the database. This is pretty cool because you can do things like this. So let's say we have the first name and last name. We want to return full name, which is a concatenation of the two. So you just say, we're going to have a string back, and it's a concatenation of first name and last name. And you're done. You get back a struct, and it has full name. Again, true reflection of the query that you used. Number 7, you can persist nested data without special model configuration. So this is related to the feature called nested attributes for, I think, in Active Record. So in Rom, it's kind of dynamic. So you can say that I have users, I'm going to combine them with tasks, and I will insert a nested data structure into my database. So we just say changeset create, give it name, and a list of tasks, which is a nested data structure, and Rom will figure out what to do with it and just create the nested data structure by like saving data into appropriate tables. So that's pretty cool. Number 8, you can use it with legacy schemas without yelling at your computer screen too much. Of course, legacy schemas can be really horrible, so I'm not saying that it will always work perfectly, but it definitely works better than Active Record. So let's say you have some really, really nasty names, both tables and columns, so you can very easily provide aliases both for relations and for attributes, and then you just work with much nicer data structures in your application. Number 9. Define custom data mappers. This is something that is basically core functionality in Rom. We have data mappers since day 1. It's just that we generate them automatically on the fly. So as I mentioned, a lot of dynamic behavior under the hood. But it's still there, and it's still one of the first-class APIs that we have. So if you find yourself in a situation where you cannot like transform, project the data using the native query interface using your database, you can still provide custom mappers that will do whatever you want with the data. All you need to do is to define a class, which inherits from a mapper, and then define method call, which receives a whole relation, and then just do whatever you want. Actually, this can be anything. It's just that we integrated Rom mappers, the built-in implementation with the setup process, so it's a little bit easier to define them and have them available. But this can be anything. It could be a proc. And last but not least, you can use changesets. You've seen changeset method on previous slides, but changesets are actually a pretty big part of Rom. They are provided by a separate gem. And they are much more than just a method called changeset in relations, because it's a whole API that is kind of separate from relations. So you can do this. What you see here is basically a custom changeset class that will transform data before it saves it in the database. And this is something that at least I've been missing in other libraries. Basically, the idea that you need to do something with the data before you send it to the database. And it's not just about like simple coercions at the value level. It's sometimes about like converting the whole data structure. So we have a pretty sophisticated API for that, this map do thing. And then you can ask for your own change set, and it's obviously a trivial example, but I'm pretty sure you can imagine much more complicated examples. So then you just ask for your own change set, and it's going to convert the data, and then it's going to be persisted in your database. So that's last but not least. And there's much more, but I need to stop. So Rom 4 is out, RC1. We're working on documentation. API documentation is like 90% done. We're working on a big update to our website where we have user documentation and some guides. This is basically a release blocker. The documentation is a blocker, so we need to be sure that the docs are good. So the documentation for the 4.0 version is available at rom-rb.org. So you can like see how it's evolving, and if you have some ideas how we can improve it, if you have any kind of feedback, please talk to us, because it's really important to know how it feels from a user perspective. I was joking that I'm literally the worst person to write documentation for Rom, because I just don't know what to write about, because I'm not sure which part should be explained. So yeah, feedback is important. You can check out our website, it's rom-rb.org. We also have a Twitter account where we just tweet about new releases and any kind of development-related news. And just check it out, because it's pretty cool. So, not sure if we have question time, but any questions?
So thank you for your talk.
Where
I
are
have two
you?
questions.
Where are you?
What about?
Hi.
I'm here. Yeah. What about migrations and connecting to the data source, for example, to the YAML or database? Thank you.
You asked about migrations?
Yeah, migrations. Migrations. Yeah.
As in migrations, kind of like in Rails, that you change structure or something?
Yeah, for a database, you can change the schema.
Yeah, we have migration API. We actually introduced auto migrations in 4.0. So we basically have now two ways of migrating your schema. One is that you just do it like in Rails. We're using SQL gem under the hood, so it's the same API. We just delegate to it. So you're just creating a file, and you say create table or alter table, and you have a bunch of methods to manipulate the schema. And we also have this new feature called auto migrations, which allows you to define schema inside your relation classes, and then ask Rom to automatically update the schema. And once you're done with a new feature that changes the schema, you can ask Rom to generate the final migration file, which will be run on production. So that's a new experimental feature that we have. Yeah.
Oh, thank you. Thank you.
Hi, thanks for the talk. I have two questions.
Again, where are you?
Here I am. Yeah, what about migrating the old legacy project, like with loads of tables, and like in your experience, how long does it take? And yeah, sorry, and the second question is, like Rails, like Active Record has a huge API, as you said, and there are like a lot of things you can do. Is there something you can do with Active Record and you cannot with Rom? Like some cumberstones people have.
What you can do with Active Record that you cannot do with Rom?
Yeah.
Yeah, you cannot do callbacks. Oh no. What do we do now? Well, Active Record has way more methods for doing the same thing, which may feel kind of convenient. So that's one thing. I think Active Record still has more advanced support for things like, for example, yeah, prepared statements. We don't support prepared statements. That's one thing. But that's kind of a more low-level thing. I don't know. Nothing comes to my mind right now.
Okay, and
What was the first question? Could you repeat that?
Migrating a legacy project from active record to Rom.
I know that people are doing this. I've never done it, so I don't have experience.
Oh, okay, thanks. Thanks.
Yeah.
One last question, okay?
One last. Okay. Can you hear me? Why don't you...
I assure you I don't see you. Oh, I was looking there.
I'm here. Why don't you use lazy loading?
Why?
Why? Yeah.
It's mostly because we want to avoid ad hoc queries. Like with Active Record, you don't know when you actually hit your database because it can happen in multiple places. There are pros and cons of both approaches. We're just trying out a different approach, and so far it works well because you have more control. Like you know where and how
exactly
you're going to hit your database.
Yeah, that's what I thought.
Sorry?
That's what I thought.
Yeah. Okay.
Okay. Thank you, Piotr. Thank you very much.
Thank you.